Welcome to the Rare Earth Exchanges podcast, where power, politics, and the world's most coveted materials collide. Rare earth elements power the backbone of tomorrow's most critical technologies. With China dominating global production, the U.S. and its allies must align strategically to ensure a stable future. This urgency prompted tech entrepreneurs Daniel O'Connor and Dustin to launch Rare Earth Exchanges, a news and insight platform built to equip stakeholders and decision makers with the tools and intelligence needed to reduce dependency and build prosperous resilience. Let's get into it.
Welcome, everyone, to the Rare Earth Exchanges podcast. I'm Dustin, joined by my co-host Daniel. And today we have a special guest, Bhaktha, the CEO of Chara Technologies, joining us talking about EV motors and everything that goes in there. Bhaktha, welcome to the show. How are you?
Hey, good, Dustin and Daniel. Thanks for having me here. Much appreciated.
Perfect. Hey, Bhaktha, could you, for those who are unfamiliar with Chara Technologies, what's the core problem you're trying to solve with EV motors in the manufacturing space?
Yeah. So as of today, pretty much all the motors that are used in electric vehicles, from the smallest e-bikes to two-wheelers to three-wheelers and the large four-wheelers, they all have this motor usually called a PMSM motor, and they work quite well. But they have these magnets in these motors, which are the neodymium ferrous boron magnets, and these need four rare earths that make them magnetic, and NdPr and TRDY. And the problems of rare earths are fairly well known now. They're expensive, they are difficult to mine and extract economically and environmentally, and one country has a 90% control over the supply chain, which happens to be our neighbor. And so this leads into a lot of supply chain issues and strategic issues. And so what we are doing at Chara, which stands for, by the way, motion in Sanskrit, we are building rare earth free motors and matching controllers for electric vehicles and a bunch of other applications.
That's awesome. And how did you get started with this company? What's some of your background?
So I was born and brought up in Bangalore, in South India. After finishing my graduation, I came to US, did my master's at Arizona State, worked in Intel for about a decade, then moved back to my hometown and became an entrepreneur in my middle age. By the way, my background is hardware and embedded firmware, engineering wise. I like to build things. And I did a startup called EasyTap, which was in the fintech space. I was in the hardware group. We ran that company for about 10 years, sold it off. And then during COVID, around that time, this was climate and sustainability was on the top of my problems we should solve. I think the biggest problem this planet has is the change in climate, I believe. And we need to solve that problem. And there is a big energy transition that is happening in this world today. We are moving away from hydrocarbons to electrons for a lot of our energy needs. And so extending this this whole situation, we saw that there is a lot of opportunity in generation, distribution, consumption of this electricity. And that's where we hit upon this idea of building an efficient and a sustainable motor. That was the kind of the whole thought process, about 6 months to 9 months to figure out what we want to do. And that's how we ended up building a rare earth free motor and a matching controller.
It's an extremely important area. And again, the impetus behind rare earth exchanges is to help accelerate the re-industrialization, supply chain changes that need to happen per your point. Part of that whole process is going to be technological disruption and moving in some cases towards motors, for example, that may not need rare earth elements as an example. Now, that being said, we typically can either start sort of at the micro level and work our way out. I think it's important to step back and look at the market today. Like if we look at the EV space today, or even hybrid space, if it's relevant, I would imagine the vast majority, if not all motors today, rare earth magnet based. Is that a correct assumption, or is there a change happening? And if so, how extensive is that change?
As of today, to the best of our knowledge, all the motors that are used in mobility are rare earth magnet-based motors. I think there is one exception we are aware of in the Tesla two motor. I think the front motor, the auxiliary motor, is an induction motor, but the main motor is still a rare earth based motor. So pretty much there are no exceptions. As I said, from the smallest e-bike to a two-wheeler, three-wheelers in India, and cars and trucks, they all have the same motor, the NDFEB based PMSM motors.
And so if we look at that space, and again, just focus on EV, because I believe you all are targeting EVs, correct? What's the ballpark market size? I guess you would be a tier one vendor in the supply chain, speak tier one or tier two. What would be the size of that market as you look at it if there is a transition to a non-rare earth element
Yeah,
type of product?
correct. So at a broader level, the total market size for all kinds of motors on this planet is about like $160 billion this year. Out of that, the traction motors, as we call them, mobility motors, is about $35 billion worldwide.
Billion. Okay.
And in India, and India is kind of at the beginning of the transition still. And in India, it's about $1 billion. And of course, given our size of the market, it's expected to grow fairly big. And all of this again, even at the risk of repetition, are rare earth magnet based motors.
Understood. So now let's drill in. Let's look at, your standard rare earth based motor versus what you all are building. Okay. Chara Technologies. How does it work? How is it different at a high level without giving away any secrets?
Yeah, no. So the way the rare earth magnet based motors work is that there is a stator, which has a coil, which where you pass the current and it generates a field, typically a rotating magnetic field. And on the rotors, we have these powerful magnets, the NDFEB magnets. By the way, these magnets are the most powerful magnets that are available on this planet. And so this field will either attract or repel the magnets and generate the torque. Very simple. That's why it works beautifully, except for the little problem of rare earths. So that's usually called the lens force in electromagnetics, the field interacting with a magnet. But what happens in a reluctance motor, which is what the technology we are pursuing, is that reluctance is the property wherein flux or any liquid always takes the least resistance path, going from a higher potential to a lower potential. And reluctance is the resistance to that flow, to that magnetic flux. And so what we do is that we still have the same stator, just like a PMSM motor, with coils around it, typically generates a rotating magnetic field. But our rotor is different. It does not have any magnets. It has this funny cross-section or a very sophisticated cross-section of the rotor, which creates these paths for this flux created by the stator to flow. And we position the rotor such that the resistance to this flux flow is higher, or in electromagnetic speak, the reluctance is high. So when we excite the stator, the rotor tries to position itself to the low reluctance path, and that is what generates the torque. And we keep moving the field, and the rotor continues to track the low reluctance path. So the method of torque generation is completely different from a magnet-based motor to a reluctance motor.
That's fascinating. That approach that you just described, is that something that's sort of known in this nascent space, or is this something that you all came up with, or is it something you already knew?
So just to be clear, be told reluctance motors is a known technology, a known concept. Apparently, the original paper is about 200 years old, goes back to 1825. And I believe this is when man invented magnetism and electricity. This is during the Maxwell days. Reluctance motors were the first motors that were proposed because they're so simple. The rotor, because we didn't have magnets then. Just another thing we have to remember is that NDFEB magnets, or the rare earth magnets, were kind of produced in the US in the 70s and 80s. And they became, very prominent in the 90s and early 2000s. So I think it was, I spoke to that professor, sorry, I forget. It's in the state of, where is a big Air Force base? Sorry, forget. If I remember, I'll let you know. We spoke, so the rare earth magnets were invented by a DARPA grant, like a lot of things were funded by DARPA, and they became prominent in the 80s and 90s. Yeah. So reluctance motor is a known technology. It's nothing new. It's not that we have invented. But these reluctance motors and truth be told, these are not seen the light of the day yet. This is still a concept. For the following three reasons. The first is that these motors are highly nonlinear. So as I mentioned, it all depends on the flux flow, and there is something called a BH curve for steel. The thing with the BH curve for steel is that it's highly nonlinear, and there is also hysteresis. That means the behavior of the flux flow also depends on what was the flux that happened just before that. So that's what makes it difficult to control these motors. And now with the abundance of computing power relative to what was available last century or last decade
Right.
also,
Right.
we have solved this problem. And by the way, it's not only us, there are many companies all over the world trying to solve this problem. Basically, we solve this non-linearity through more better algorithms.
Sorry, better
Algorithms, better software. And that's why actually if you search on the internet for reluctance motors, there are a bunch of people who call it software controlled motors because
Got
it's
it.
the software which,
Okay.
that is the key. And with the
Okay.
advent of better power electronics, which can
Okay.
switch faster,
Okay.
add more computing power, we kind of solve this non-linearity problem
Okay.
and make it work.
Here's a
Very
more critical question that I put together. Can rare earth free motors truly match the torque density and efficiency of the rare earth magnet motors at commercial scales? There's coming up with a prototype. There's matching or beating the existing approach, and then there's scale. And it sounds like we're still at phase one. Am I correct on that?
You're 100% correct, Daniel. So to answer your question, our motors, which we are selling now in small quantities, we just started shipping from this year to customers in India and a couple of customers outside India. The efficiency of our motor is as good as a PMSM motor. And especially the duty, what we call as a duty cycle efficiency, the efficiency at all points is actually very better than a PMSM motor. But we do give up something. This we are dealing with physics. And our motors are about 15% heavier and bigger than a PMSM motor. So that's the second part of your question, which is the torque density or
Right.
the power density. So so again, there are various kinds of motors, but comparing similar motors, the power density of a good PMSM motor is about 2.1 kilowatt per kilogram. We are at about 1.7, 1.8. Now, what does this mean for us in India, right? Our market is slightly different than the US. So three-wheelers are very popular. You might have seen pictures.
Right.
I don't know.
Right.
Yeah. Right. So a typical PMSM motor is about 15 kilograms, the existing motors. So our motors are about 18 kilograms. There's 15% difference.
Little heavier.
Little heavier. But if you consider the gross vehicle weight of a three-wheeler in India is about 750 kilograms, where the 3 kilogram is a wash. So there is a mental block that our motors are heavier, bigger, which is true. But I believe that for many applications, it will not make a difference.
Well, I mean, when we step back and extrapolate out, it could make a huge difference if your supply chain is certain, and
Absolutely.
you could. I mean, so there's other considerations. Now,
Correct.
let's talk about IP without going into too many details, but at a high level, how do you ensure your approach is protected from commoditization from large OEMs that could come in potentially at scale and just copy and paste, for lack of a better word?
So once we start selling our motors, which is here, people can look into the motor, reverse engineer very easily, and there are people who do that for a living. So is the hardware, but the key IP which we have IP in the motor design, but the key IP which we have not even patented, is the algorithms which control the motor, and that
Gotcha. Right.
is inside the controller, and that cannot be copied, and that is what gives us the barrier of entry from other competition.
But you could, correct me if I'm wrong, you could build a business licensing those algorithms to other OEMs or tier one or two supply chain vendors, right? Maybe or no?
Yes. So we are a product company. We have our own manufacturing plant wherein we manufacture our motors and controllers and start selling to our customers. But having said that, we have a manufacturing and a GTM go-to-market agreement with a very large company called Greaves Cotton. As you can tell by the name, that company has been around for 165 years. It came from the British era, when the British ruled this country. So we have given the license to manufacture our motor. So they get all the details of the motor and the hardware so that they can manufacture. But our software we give only in object form. So that way they can never copy. So that's what we are doing. And we could potentially do it with other large companies too.
Yeah, that makes sense because the value of your company, if it's in partially in that software that, and you've got everybody licensing it. What about economics, total cost of ownership? I understand you're still at the stage you're at, but in modeling, does this approach equal the status quo? Is it higher? Is it lower? What's any high level thoughts on that?
Yeah. No, this is once you have started selling, this is a question that we get asked very often. We go sell our motor to our customers, we convince them. At the end, it's always about price, especially in a cost sensitive economy like ours. So today it's a known fact, verifiable fact, that 40% of the cost of the motor, rare earth magnet based motor, is consumed by the magnets. 40% at current prices. So we remove the magnets, we add a little bit more steel and copper, and steel and copper are much cheaper. So if you look at the price variations, the price differences, right? Basically, there are three materials that go into the construction of the motor, Daniel. There is steel, there's copper, and there is magnets. The steel is about dollar per kilogram today. Very close to, very close to. Copper, as you know, sorry, I will speak in kilograms. You have to convert mentally to units. I should have been, next time if I speak to somebody, I'll prepare myself. Copper is about $12 per kilogram. Rare earth-based magnets, which is the ND FeB magnets, they are about $80 per kilogram. They're like an order of magnitude.
Yeah.
So we remove the magnets, we add a little bit more steel and copper. So our motors, as of today, we have done the BOM analysis. The large company where we are licensing to has done the BOM analysis. We are about 15 to 20% cheaper in the long term once we have the volumes. Yeah. So I think that is it. Apart from the freedom from dependence on critical metals.
So from this, so viewers understand from this perspective, at least from the model at scale, prices 10 to or 15%, 20% lower. You have no rare earth element dependency for that motor.
Yes.
Therefore, the security premium that we're seeing going into some of these rare earth elements and magnets goes away.
Yes, absolutely.
Okay. Now, here's an important, more detailed, nuanced question. There's other pieces, Stator steel, there's different elements that still may come from China that you are using potentially. Are there other components, assemblies, elements inside that come from China as part of the motor's makeup?
So today, all the materials that go into the construction of our motor is sourced from India, which is aluminum, steel, copper, and ferrite magnets. There is a little sensor which senses the position of the rotor that has a small IC that is imported, and then there is a controller where our algorithms reside, where our software reside. That controller is basically one large microprocessor, some driver ICs, and MOSFETs or silicon carbide devices. The situation in India, as you might know, is that we still don't have semiconductor fabs in this country. So all the semiconductors, the processor, the driver ICs, the power switching devices like MOSFETs and silicon carbide MOSFETs, they're all coming from outside, not necessarily from China. There are multiple fabs all over the world. I think most of the ICs are coming from Taiwan. Taiwan is a powerhouse of semiconductor manufacturing today. And as a country, India is heavily investing in semiconductor manufacturing. We believe that in about 3 to 5 years, we should be sourcing a bunch of the components from India. But there is no single country dependency on the semiconductors as well.
No, I mean, this is what it's about. This is what we want to highlight on the Rare Earth Exchanges platform. Although it says Rare Earth Exchanges, again, the goal is to create resilience in supply chains. That's what the whole mission is here. Okay. So now, if we take a step back, look at the company, I think it was founded in 2019. I believe you've raised 6 or 7 million US dollars. Is that correct? My question is, you were founded in about 2019. Is that correct?
Yes, November of 2019.
Okay. Okay. So, and as far as commercialization, what does that look like? What's the timeline for your first product sales and an accounting of your sales and some kind of commercial cadence?
Yeah. So we did fundamental R&D in electromagnetics, mechanicals, thermals, hardware, and the critical software algorithms. We took about 4 years to come up with a motor and a controller which is good enough to sell. Last year, when we started selling, we sold about 200 motors the last calendar year. So we had a little bit of revenue. But this year is when we will kind of record our first large revenue. So this year we are targeting a order book of about, I'm making a mental calculation, of about $6 million. And a shipped revenue. That means we ship the motors of about $2 million. So, in terms of motors and controllers, this will be about an order book of about 5,000 motors and shipping of about 2,000 motors.
That's really impressive. You're taking off commercially. You can see a pathway to growth.
We have spent 6 years doing R&D, so it's high time we started shipping.
Are the sales coming from one company or are they multiple companies?
So where we are today is that we have about 8 customers who are wrapping up. Each of them have placed about 500, 700,000 motor orders. Most of them are in India. Only one is outside India, which is in Europe. And so we are fairly distributed across customers. But more importantly, Daniel, even though our motors are traction motors for 2-wheelers, 3-wheelers, and small 4-wheelers, interestingly, it has been adopted by agricultural equipment, tractors, small tillers. They also need motor. They're also getting electrified. And this industrial machinery like forklifts and the loaders, they're also getting electrified. So our motors are going not only into what we call as on-highway vehicles, vehicles which can drive on the road, also vehicles which you don't drive on the road, like agricultural equipment, industrial equipment, and the same motor and controller. So technically, they're also electric vehicles, but we call them off-highway vehicles. So there is significant amount of volume from off-highway vehicles also.
Totally makes sense. Bhaktha, this is all very impressive. Dustin, I think we're getting close to the end, but I just want to say it's extremely impressive what you're doing here. You're executing. 6 years is not that long for such a profound change. So very exciting to see.
Yeah. There's a lot of interest from the governments too, but we've not received much support yet. The government of India is speaking to us because it is a strategic problem. So incidentally, there is a venture capital firm called In-Q-Tel. Have you guys heard about them? So In-Q-Tel is the venture capital arm of
That's right. Yes.
So we had a conversation with them. They reached out. Nothing came out of it. Apparently, In-Q-Tel has a charter to invest only in the US. They're still not investing outside US. I think they've just started the Singapore arm. But what is interesting is that there is some push by the governments, both here and there and all over the world, because energy is critical, right, for a society, and we can't be dependent on one country. So even the governments are looking at it.
So I will say, we track all of these things pretty closely, and the Indian government is taking this all very seriously. They're putting money in. They're going to have to put more money in. And what you all are doing has to be part of a portfolio of a strategy to diversify. So I would say, and we have people from the Indian government coming to Rare Earth Exchanges on a daily basis, I believe. It's important that this class of activity is part of a strategic portfolio. It's not everything, but it's important. It's something. It's important.
Yeah. I'd just like to point out that we were struggling to sell our motors and controllers last year and even beginning of this year because new technology, small startup, uh, and there is no long-term history of reliability and safety of our product. But after the geopolitics that happened in April, May,
Yeah.
I think people are looking at it a little bit more kindly.
Yeah.
And huge tailwind. Yeah, the embargo by China has created a huge tailwind for.
Yeah. Yeah. There's no question that,
Absolutely.
Dustin.
So just kind of wrap up here. We kind of like to ask a lot of our guests, like, what does it look like 5 years down the road? What do you hope to see from your company in terms of progress and what does success look like?
So for us, there are three things. Number one is that we want to be recognized in this country and maybe globally as the center of excellence for motor design, newer technologies, and design and manufacturing. The second one is something closer to our hearts. We want to build a product made in India for India and export it to the world. And the last one, commercially, the public markets were not mature in India, even when we started this company. The only way to a startup to exit was an M&A. That's what happened to my previous startup. Now the public markets have matured and a lot of companies are doing IPO in India. And we would like to do that at the end of the decade, 5 years from now, when we have about 200 to $300 million revenue. A huge opportunity. I think sustainability, geopolitics are creating tailwinds for us. We just have to raise capital and execute well.
Absolutely. And for those who are interested in the work that you guys are doing, how can they connect with you best? Visit your website, find you on LinkedIn. Where should they go?
Both of them will work. Our website works, chara.co.in, and we watch it very closely. By the way, we have got a lot of customers through our website, including that European customer. So the website is the best way to reach us. LinkedIn also it works for either you can go to our company LinkedIn page or my LinkedIn page. We will always respond quickly.
Absolutely. That's great. That's great to hear your website is getting you customers.
Yes.
Awesome. Bhaktha, thank you so much for being on the show with us and sharing about your company and the work that you guys are doing. As Daniel said, it is very important what you're doing, and the success you've seen so far in a short amount of time is nothing short of remarkable. For those who are listening to the show, if you like this episode and want others to hear it, please like wherever you listen to this show. If you don't want to miss a future episode, please subscribe so you get a notification when we have a new episode come out every week. Bhaktha, again, thank you so much for taking the time to be on the show with us. And hopefully we'll have you again in the future to give us an update.
Yeah. Thanks, Dustin. Thanks, Daniel. Would like to come back on this show 5 years from now when we go IPO and talk about it. I don't know what will be the state
Absolutely.
of the world then, but I'm pretty sure it'll be more confusing than what it is now.
Absolutely. Thank you again.
Thanks. You guys have a good day. Bye.